Hello everyone. In this video I'm going to explain the exponent rules. Uh, Actually we studied in the class and I'm sure you know all of them. So I'm recording this one and you can watch anytime if you faced any problem, or if you forget some of them you can watch this video. Okay, let's start with multiplication 1. The multiplication rules, we had two very important for exponent. The first one, if the base are same, like a to the power of n multiply a to the power of m. When the base are same and the exponent or the power are different, so we say it's equal to a, we will take one base and we will add the exponent or the power n plus m. A numerical example, like 2 to the power of 5 multiplied by 2 to the power of 7. So it's equal to 2, 5 plus 7, that's equal to 2 to the power 5 plus 7 is 12. The second one is if the base are not same and the power or exponents are the same, like a to the power of n times b to the power of n. We will multiply the base, these two together, we'll multiply the base. We say a times b and we'll take one power. A numerical example is like 3 to the power of 5 multiplied by 4 to the power of 5. Here the base are different and the power or exponents are the same, so we will multiply. We say 3, we'll say 3 times 4 and we will take one power, or equal to 3 times 4, 12 to the power of 5. And if all of them are the same, if like we have a to the power of n times a to the power of n, if all of them are the same, so you can use this law or this one. It's you can write like a to the power of n plus n, or you can say a times a to the power of n. So both of them are correct. Like 3 to the power of 4 multiplied by 3 to the power of 4. So you can say 3 to the power of 4 plus 4 equal to 3 to the power of 8, or you can say 3 times 3 to the power of 4, it's equal to 3 times 3, 9 to the power of 4. So both of them are correct. So it's the multiplication. After I've explained all the rules, so I will solve then next question from all, then you know how to use different law in one question. So this part is for multiplication and it's kind of very easy. Let's move to the division. The division rules are same, like not same, so it's like similar to multiplication. The first one, if the base are same, like a to the power of n divided by a to the power of m. Here the base are same. This one is a, this one is a, and the exponent are different, these two. If the base are same, we will take 1 in division. The numerator exponent or power is minus the denominator power m. Numerical example is like 5 to the power of 9 divided by 5 to the power of 3. So it's equal to, because the base are same, we'll take 5, and we say 9 minus 3. It's equal to 5. 9 minus 3, how much? It's going to be 6. The second one is if the base are different and the exponents are the same. Like a to the power of n divided by b to the power of n. Here the base are different. We have different numbers, but the power are the same. This one is n and this one is n. It's equal to, if you have like this, we say a over b, a divided by b, and we'll take 1 power, take 1n. Numerical example is like 15 to the power, sorry, I said 15, I wrote 10, okay, no problem. 10 to the power of 3 divided by 2 to the power of 3. Here the base are same, like the base are different. Base are different and the power or exponents are the same. It's equal to 10 divided by 2 and take 1 power, one of them, because both of them are the same. So it's equal to 10 divided by 2, it's 5, and 1, 3. So the answer is 5 to the power of 3. And the third one, actually there's no third one, so just I added this one that tell you that you can use first law or the second law. If both of them are same, like a to the power of n divided by a to the power of n. If both of them are same, so of course you know the answer is 1, even it's no need to use any rule or law. Or you can also use the first one or the second one. Even if you use the first one, so you have to write a to the power n minus n. So n minus n is 0, and any number to the power 0 is 1. Again, it's become 1. Even if you use the second one, also the same. A divided by a to the power of n. A divided by a is 1, power of n. 1 to the any power, it's again 1. So there's no difference. So it's no need to do that one. In division, when numerator and denominator are the same, so directly write the answer is 1. Another rule is if you have power to the power, like a to the power of n, then to the power of m. Or even you can add more to the power of, for example, p. It's equal to a to the power of n times m times p. Just multiply all of them. Numerical example like 3 to the power of 2 to the power of 3 to the power of 5 the answer is equal to 3 to the power of 2 times 3 times 5, and it's equal to 3 to the power of 2 times 3, 6, 6 times 5, 30. So it's the answer. Another one, if you have a negative power like a to the power of negative n, when you have negative power, you have to change it to the positive, and it's very easy. Just write 1 over a to the power of n. Let's become positive, like very simple. Or if the negative is in denominators down, like if you have 1 over a to the power of minus n, if the negative is here, just take it up on the numerator, just write a to the power of n. It's going to be positive. And the examples are very easy, like 5 to the power of minus like 7, it's equal to 1 over 5 to the power of positive 7. Here it changes to the positive. Or if it is down, for example, if you have 1 over 5 to the power minus 7, so you can take it up, it's become 5 to the power of positive 7. Or if you had both of them in one question, like a over b to the power of minus n, like this. It's equal to, just change the place of a and b, like take b to the numerator, b over a, the n gonna be positive. It's positive n. Or if you had them separately, like a to the power of minus n divided by b to the power of minus m, just change the places, both of them gonna be positive, right? B to the power of m positive over a to the power of n positive. The numerical example is also very easy. 2 over 3 to the power of minus 5, it's equal to 3 over 2, the negative minus gonna be positive. Or if you had like this one, 2 to the power of minus 5 divided by 3 to the power of minus 4, it's equal to 3 to the power of positive 4 over 2 to the minus 5, positive 5. That's much easy. And some other rules, like actually they are important, like if we had any number to the power of 0, it's equal to 1. Also, it's not important which kind of number you have, like 5 to the power of 0 equal to 1, or write a big number to the power of 0, it's equal to 1, or any decimal number 3 or 4 to the power of 0, it's equal to 1. And another one, any number to the power of 1, it's equal to itself, it's equal to a, or like 11 to the power of 1, it's equal to 11, or any other number. And there's another one from root, square root, that is important. Also, if you have like a square root of a, you can write this as an exponent. You can write a to the power of 1 over 2. It means when your number had power as a fraction, so it means it's a square root. Or if you had like a to the power of m, this like a square root of a to the power of m, or in general I will write instead of this square n, to make a general rule, it's equal to a to the power m over n. This is the rule. Like 5 square root of 5, it's equal to 5 to the power of 1 over 2. Or if you had like 7 to the power of 3, this one is 2, so it's 7 to the power 3 over 2. It's like this. It's very simple. Okay, let's solve these questions together. This one just count, now you know 1, 2, 3, 4, 5. It's 3 to the power of 5. This one is 1, 2, 3, 4, 7 to the power of 4. Actually, you have these papers and the other pages I will solve together. Now here, and you know the answer is very easy. 1, 2, 3, 4, 5, 6, 8 to the power of 6. And you do this one, you do, so till here, all of them are easy. So let's come here. We have 3 times 3 to the power, so you can say 3 times 3, 9 to the power of 4, or you can say 3 to the power of 4 multiplied by 3 to the power of 4, because you know inside the brackets it means this 4 belongs to both of them. So the answer is 3 to the power of 4 plus 4, then 3 to the power of 8. This one is also very easy. The base are same, just write 7, then write 2 plus 7 plus 4 plus 0. It's equal to 7. 2 plus 7, 9, 9 plus 4, 13, 13 plus 0 is 13. Now you know you can, okay, this question, I will do this one. Look, we have here 5 and 8. So you can take this 5 with these two 5s and 8 with 8. I'll take this 8 with this one. So if we take 5, we have 5 to the power of 3 plus another 5 here, power of 0, plus another 5 here, power of 8, and it's 5 to the power of 3 plus 0, 3 plus 8, it's 11. The same here. Now you know the rules and you know how to do it. It's also power to the power, it's 3 to the power 4 times 6, 24. Do also the same, do the same. This one is also easy to do the same, like 2 to the power of 3 times 2, 6, multiply by 2 to the power of 3 times 5, 15. Now 2, 6 plus 15, 2 to the power of 21. And here you're going to multiply all powers. 5 to the power of 2 times 3 times 2 times 10, and it's equal to, you know what should you do. Here it's negative, change it to the positive, like this, it's very easy, or 1 over 64. This one is the same, we multiply, it's multiplication, also you can take it up to change it to the negative, so just play with it to remember the rules. And this one also the same. Let's go to the other page. This page, the first one is also, it's the same like other question we solved. The second one is easy, you know now how to solve, and you did actually before. This one is the same, so let's go for division. Here 3 to the power 8 minus 6. So 3 to the power of 2. It's very easy. This one first write the numerator as an exponent, like 7 to the power of 1, 2, 3, 4. Then 7 to the power of 8. It's equal to 7 to the power of 4 minus 8. Here is a little trick that the answer gonna be negative. So 7 to the power of negative 4, because you know 4 minus 8, so the answer is negative 4. Or you can change it again to the positive, or 7 to the power of 4 positive. The same, these two also, and this one also the same. There's no difference, just I added another number to make it a little tricky, but you know this one. First you can write 4 to the power of 8. I think this one is 9, or maybe 0, because it's little small. I have to zoom a little more. 4 to the power of 6. Then the answer is 4 to the power of 8 plus 9, 17 divided by 4 to the power of 6, or 4 to the power of 17 minus 6, 4 to the power of 11. This one is the same, all of them are easy, you know that. But here, a little tricky question. I'm going to explain this one because if you remember, we had a rule like a to the power of n divided by a to the power of n m. So if you remember, we said the base are same, we will take 1 n minus m. Here we have one minus from relation or from the rule. So here it has another negative. So this one is not this one. Be careful here. Don't mix them together. And the answer, it's like I write 4 to the power of minus 8. Then minus is this minus from rule. Minus 12. It's equal to 4. Now both of them are negative. Like minus 8 plus minus 12. The answer is minus 20. And you know this point. Also we studied in the class. And the same here. Also I will explain this one here. First, let's simplify the denominator. 7 to the power of minus 5. Here down we have 7 to the power of 8. 8 plus minus 11. Yeah, plus minus 11. It's equal to 7 to the power of minus 5. Denominator is 7 to the power plus 8 plus minus 11, because this minus is from here. It's minus 11. The answer is going to be minus 3. Because 3 minus 11 is bigger. So here, now we simplified. So we write 7 to the power of minus 5. And then this minus from the rule. Minus. Then again here our number has another minus. So I will write in the bracket just to separate them and don't mix together. So the answer is 7 to the power of this minus 5. And you know that this minus, because it's in the bracket, so it's multiplier. And minus times minus plus 3. So the answer is 7 to the, now it's minus 5 plus 3. The answer is minus 2. Just a little tricky, but because we solved in the class and I know that you can solve these kinds of questions easily. And this one also the same trick, you can solve it. Also the same, and also the same trick here. Question 23. And the other questions are the same, and you can answer all of them. Let's go to the last page from this part. Okay, this part also, the questions are look a little difficult, but actually they are very easy. This part, look, just write 3 to the power of, just multiply 2 times 4 times 3, then multiply by the other 3 is to the power of 10 times 9 times 0. This one is 2. It's equal to 3 to the power of 2 times 4, 8. 8 times 3, 24, multiply by 3. 10 times 9, 90, multiply by 0, it's 0. If you remember, we said any number to the power of 0 is equal to 1. So this one, 3 to the power of 0, it's going to be 1. 1 multiplied by 3 to the power of 24 is 3 to the power of 24. It's very easy. And this one also the same, but a little tricky question here. I put, you can write 2 plus 4, it's 6 to the power of 5, multiply by 10 minus 4 is 6, then multiply these two also, 2 times 8, 16. Look, now it has the form of multiplication when the base are same. When the base are same, take 1, like 5 plus 16, and then it's equal to 6 to the power of 21. This one also the same. It's very easy. We solve it like 4 to the power of 9, multiply by 3 to the power of 9, multiply by 3 times 3, again 9, multiply by 9 to the power of 1, because when it doesn't have 4, it's 1. Then these three numbers, they have same power or exponent. If you remember, when we have like a to the power of n multiplied by b to the power of n, so we'll multiply the base a times b, and we take one exponent or power. So here we do the same with these three, because three of them they have the same power or exponent. I can write 4 times 3 times 3, then take 9, multiply by 9 to the power of 1. Then it's equal to 4 times 3, 12. 12 times 3, 36. To the power of 9, multiply by 9 to the power of 1. It's the answer. This one also, it's look like very, very big question, but actually if you look to the last part, look, first maybe you think it's difficult, but when you look to the last power, you can see here 0. If you remember, we studied that if any number to the power of 0 is equal to 1, so this one as a number, this one from here, it's a whole one number, and the power is 0. When the last one is 0, it's no matter what do you have inside, the whole, it's going to be 1. And this part, you have 5 to the power of 12, multiplied by 3 to the power of 3 times 4, it's 12, multiplied by 2 plus 3, 5, 2 times 6, also 12, and this part is 1, even it's no need to write in multiplication, because in multiplication 1 multiplied by any number, the number itself. Here all the power or exponents are the same. We'll multiply the base, 5 times 3 times 5, then we'll take one power. Or we can make it more simple, 5 times 3, 15, 15 times 5, it's 75. Oh, 75. 75 to the power of 12. This one also, it's like maybe first you think it's difficult, but you can simplify the numerator. You can write 3 plus 5, 8 to the power of 9, then 16 to the power of 3, and after this, look how much it's simple. You can also, when the base are different and the exponent are different, so you have to simplify. This one is enough because 8 to the power of 9, it's going to be a very big number. If you simplify like this also, it's acceptable because 8 to the power of 9, it's going to be like 8 times 8 times 8, 9 times. You have very big number. This question, you can take this 2 with this 2 and 4 with 4. Let me erase this one and solve it. Or you can take the numerator, all of them are 4. You can write 3 times 4 times 2, take 1 4, divided by 2 times 4, and take 1 2. Then you can write, I will write here, 3 times 4, 12, 12 times 2, 24, to the power of 4, and here 2 times 4, it's 8 to the power of 2. But here there is another trick I think I didn't tell you in the class, so I'm going to explain it here. With that one you can simplify this question, because here the exponent are not same, it's 4, it's 2, and the base are also not same, but you can simplify it. How, I will tell you. I will explain it here. For example, if you have like 4 to the power of 2, also you can write, instead of this 4, you can write 2 to the power of 2, and we have another power, this one, we will write here. So I can write 2 to the power of this 2, 2 times 2, 4. Look, I change 4 to the power of 2 to 2 to the power of 4. Or, for example, if you have like 16 to the power of 7. Instead of 16, I can write, if you want to change like 4, you can write 4 square, 4 to the power of 2, because 4 to the power of 2, it's 4 times 4, it's going to be 16. And the other power, you have 7. It's equal to 4, 2 times 7, 14. Look, I changed 16 to the power of 7 to 4 to the power of 14. Or you can change as a 2. Instead of 16, I can write 2 to the power of 4. Yes, because 2 times 2 times 2 times 2, it's going to be 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So I can write this one. And the other power is here we have. So also I can write to the power of 7. It's equal to 2 to the power of 7 times 4, 28. And instead of 16 to the power of 7, I can write 2 to the power of 28 or 4 to the power of 14. You can change it. So let's apply this change here and check that how we can simplify this question. Let me erase this part. I erased all of them. Okay, I will erase this part. Okay. Now instead of 8, I will write 24 to the power of 4, Instead of 8, I can write 2 to the power of, let me check here. So I can write, instead of 8, I can write, look, instead of 8, I can write 2 times 2 times 2. Because 2 times 2, 4, 4 times 2, 8. And we have 1 to here, all of them to the power of 2. But if you do till here, it's also okay, but maybe this step to make you a little confused, but it's very easy. Also, I can write this one. I can write this part 2 to the power of 2 multiplied by 2. Instead of these 2, 2 and 2, I took this like this, and I write to the power of 2, like this. Then this power is belong to this one and this. I can write 2 to the power of 2, then power of 2. I want to separate them, then 2 to the power of 2. So this one is going to be to the power of 4 multiplied to the power of 2. So I will write it here, to the power of 4 multiplied to the power of 2. It's equal to, now I will take this part together. I will say 24 divided by 2 to the power of 4 multiplied by 1 over 2 to the power of 2. 24 divided by 2, it's gonna give us 12 to the power of 4 over 2 to the power of 2. Even you can go and make it more simple.